Hello, so let's have a look at another way which we might want to simplify something. For example, algebraic fractions. So let's have a look at this. We have a over 4 plus b over 5. Well, to simplify something in this context, I think just write it together as one fraction. Now, you don't need to worry about anything here. It's just exactly the same as ordinary fractions. The fact we've got variables and algebra mixed in doesn't make a blind bit of difference. So here, if we want to write it as one fraction, we need everything over the same denominator. So let's look for a common denominator of 4 and 5. Well, a common denominator of 4 and 5 is 20. Like 20 is in both the 4 and the 5 times tables. So I want a 20 here and a 20 here. Then I just need to think, well, okay, what have I multiplied the first fraction by in order to get a 20 on the denominator? It was 4, I want 20, therefore I must have multiplied by 5. So I also need to multiply the numerator by 5 as well. So I end up with 5a on the numerator. Let's think about the second fraction then. Well, what have I multiplied by to get 20 on the denominator? It was 5, I've now got 20, I must have multiplied by 4. Which means I need to also multiply the top by 4 as well to get 4b. So in total, it's all over 20. Remember, the 20 stays the same. It's just adding fractions together. I end up with 5a plus 4b. Okay, not a lot more that I can do with that because there's no common terms and common like terms on the numerator. Let's have a look at this next one then. So I've got 5 plus b over 4. Now here, it's awkward because the 5 isn't a fraction. So I need to write it as a fraction. Well, that's not too bad. Like 5 over 1 is just simply 5. Think about it. Remember, the fraction just means divide. 5 divided by 1 gives me 5. Then I just look for a common denominator of 1 and 4. I think 4 works. So 4 and 4, that's in the 4 and the 1 times table. So let's have a think. What have I multiplied the first fraction by in order to get a 4 on the denominator? I must have multiplied by 4 because it was 1, I wanted 4, I must have multiplied by 4, which means I also need to multiply the numerator by 4 as well. In other words, 5 times 4, well, that's 20. Great. Now, what have I multiplied the second fraction by? Well, I haven't really multiplied by anything, but if you want to, I could have think I've multiplied it by 1. So therefore I have b multiplied by 1, which gives b as well. So if I write it as one single fraction, it's all going to be over 4. I end up with 20 plus b on the numerator, just like that. Okay, let's have a look at this one then. So again, I want the same denominator on both fractions. So what is in both the 2 and the 5 times table? I think 10 is in both the 2 and the 5 times table. So let's go with 10, and then we have a 10 there. Notice I'm keeping the sign the same in the middle, all right? Now, let's have a think. So what have I multiplied this fraction by in order to end up with a 10 on the denominator? I must have multiplied by 5. Which means I've got to multiply the entire numerator by 5. That means multiply the entire of a plus b times 5. So really what I end up here is 5 multiplied by a plus b. Let's think about the second one. Well, what have I multiplied a over 5 by in order to end up with 10 on the denominator? I must have multiplied by 2. So that means that I also need to multiply the numerator by 2, which leaves me with 2a. Now this is really what I end up with here. So I end up with 5 multiplied by a plus b minus 2a, and that's all over 10. Now just be careful here, I could also expand this bracket out, like I could simplify. So this 5 has to visit everything inside the bracket. So 5 multiplied by a gives me 5a, and 5 multiplied by b gives me 5b, and everything else stays the same, so it's still all over 10. Okay. Now let's think here, have a look. Could I collect together like terms? Yes, I could. I've got a 5a, and I'm taking away another 2a. How many a's do I end up with in total? It must be 3a. And I still have 5b over 10. So there's my final answer there. Okay, so a little bit more work, but not too much. Okay, so this one now, we just need to be a bit more careful because we need to make sure that we have the same denominator, and there's x's now in the denominator. So let's think, okay, what is in both the 2x and the 5x times table? Well, you're happy there's an x on both of those fractions. So I don't need to worry about the x's. Really all I'm looking for is something that's on both of those denominators. So 2x, 5x, I think 10x is in both of those times tables. So we're looking for 10x. By the way, if you couldn't see that, the easiest way of getting a common denominator is just multiply those two things together. So 2x and 5x, okay? But let's go for 10x. So we have 10x here, and we have a 10x here. And we're taking them away from each other. Well, okay, what if I multiplied this fraction by in order to end up with 10x on the denominator? I must have multiplied by 5. Like 2x times 5 gives me 10x, which means I also need to multiply the numerator by 5 as well, which gives me 15. Okay. Then let's think about the second one. Well, I have a 10x on the denominator. What have I multiplied by? I must have multiplied by 2, because 5x times 2 gives me 10x, which means I also need to multiply that numerator by 2 as well, which gives me 14. Okay. And then it's just a case of writing it all over 10x. I have 15. I take away 14. Oh, look, that gives me 1 over 10x. Okay. So let's have a look at this one now. Now you remember the easiest way of getting the same denominator or a common denominator is just to multiply those two things together. So in other words, I'm looking for a common denominator of y times z. I've just literally multiplied both of those denominators together, and I still have the subtract in the middle. So let's think. My first fraction, I've multiplied by y. I had yz on my new fraction. I must have multiplied by y, which means I also need to multiply the numerator by y as well. Let's have a look at the second fraction. I started off with y on the denominator, and I ended up with yz on the denominator, which means I must have multiplied by z, which means that if I multiply the numerator by z as well, I end up with 12x times z. Okay, so in total, I end up with a common denominator of yz, and on the numerator, I end up with 5y, take away 12xz. Okay, fantastic. Let's have a look at these next two then. So slightly more tricky, but just stick with it. Okay, so let's have a look. The easiest way to get a common denominator is just to multiply them together. So t plus 1 multiplied by t minus 3. You notice there that I've bothered to put the brackets in because I need to make sure that it's the entire of t plus 1 multiplied by t minus 3. If I didn't put them there, then it'd just be like the 1's multiplied by the t. It's not right. You need to multiply the entire of that by the entirety of that. So let's think. I've got that on the same on both fractions, so t plus 1 and t minus 3, like so. So what have I multiplied the first fraction by in order to get that denominator? Well, I had t plus 1. I ended up with t plus 1 multiplied by t minus 3, which means I must have multiplied this by t minus 3. Okay, let's have a look at the second one then. So what have I multiplied that denominator by in order to get t plus 1, t minus 3 on denominator? I must have multiplied by t plus 1. So I had 4, and I've multiplied by t plus 1. You notice I'm using the brackets. So whenever you're multiplying by a term which has multiple terms in, so multiplying by something like t plus 1 or 3xy plus 7z, anything which had multiple terms in, make sure you put them in brackets. Then you can't go wrong. So okay, in total, on the denominator, I have t plus 1 multiplied by t minus 3. But then the numerator, well, I wonder if we can expand this out in our heads. We have 5t minus 3. So 5t minus 15, like the 5 being multiplied by the t gives me 5t. And then the 5 being multiplied by negative 3 gives me negative 15. Then likewise here, I have the 4 has to visit everything inside this bracket. So I have 4t positive. And then I have 4 multiplied by 1, which makes 4. So in total, I have 5t plus 4t, which makes 9t, and then I have negative 15 plus 4, which makes negative 11, and I still have the same denominator. You notice you could expand the denominator out if you wish. I'm just going to leave it like that, just for the sake of time. Okay, so this is a very, very similar case to the last one. I'm looking for a common denominator. Remember, the easiest way to get a common denominator is just to multiply those two things together. So y minus 2 and a y minus 3. And that's the same on both of these things. Minus 2 and y minus 3. Okay. Now, just for the sake of simplicity here, because I've got a minus in the middle, and I know I'm going to mess around with multiplying, I'm going to write the minus on the numerator. So I'm going to write this as plus minus y. You don't have to, but this is just for the sake of argument. Okay. So here we have, on the first fraction, what have I multiplied by? Well, I've multiplied by y minus 3. So I have y multiplied by y minus 3. Okay, in the middle I've got plus. Okay, and then I have negative y. In fact, I'm going to leave it. I'm going to leave it with negative there, just for the sake of simplicity. So we're going to have y multiplied by, well, what we're going to multiply by? Y minus 2, like so. Okay. Now here we just have to be careful. You just kind of have to think of this negative and this y together. So that's why I wrote it originally on the numerator. So let's have a think about this. we have the same denominator, y minus 2, y minus 3, okay? Expand the first bracket out, I get y times y, which makes y squared, and y times negative 3, which makes negative 3y. But then here you need to be careful because it's the entire negative y which I'm multiplying out. So negative y multiplied by y gives me negative y squared, but then also negative y times negative 2 gives me positive 2y. So collect together the like terms, I end up with the same denominator, y minus 2, y minus 3, okay? And then I just collect together like terms. So I have a y squared, but I'm taking away a y squared, no y squareds, and then a 3y and a positive 2y, which makes a negative y, like so.